We're asked to find the maximum point for this equation. How do you find the maximum point of an equation? Well, those are our critical points, and so we're going to take the first derivative and we're going to set it equal to 0 to find our maximum. Because this is where, a maximum is where we're going to go from increasing to decreasing or decreasing to increasing. In other words, we're going to have a 0 because we're going to have that peak in our slope. So our first step is to take the derivative, and looking at this, we have a quotient. So we're going to do the quotient rule. So y prime, our slope, remember this is our slope, okay? We're going to do low d high, okay, minus high d low, which is going to be point. So let's see here, 25 times 2x, because I'm bringing the 2 down and I'm timesing it by this, all over the bottom squared. Okay, this is the equation for our quotient rule. Now we're going to clean this up a little bit. So let's see what I got here. I have 10, 1 plus 0.25x squared minus, let's see here, this is really 1/4, right? So 1/4 times 2 is 1/2, so this is minus 5x squared. Okay. And then all over my bottom. And then I'm going to do a little bit more cleanup. So I'm going to do 10 plus, let's see here, decided that was 4, right? So it's 10/4, which is 5 halves x squared minus 5 halves. And I'm going to just keep going here for a minute. 10, and I'm going to have minus, so this is 2.5, so I'm going to have minus 2.5 x squared. Okay, so I got this far. I have my slope. Now, to find the maximum, I'm going to take this, which is my first derivative, and I'm going to set it equal to 0. Now, when I set this equal to 0, a couple of things. First of all, when will this be 0? When the top is 0, right? Because if the bottom was 0, it'd be undefined. And this can actually never be undefined. Why can't it be never be undefined? Because this here is going to give me a positive, right? This is always a positive. That's make a positive. So this is going to be a positive. That's squared. That's going to be a positive. I'm never going to get a 0. No matter what I put in here, I can never get this to be -1, which is the one thing that would give me a 0, because this is always going to be a positive. So I don't have any undefined points, which I might have to be concerned about. So I kind of, work through the logic of that. And then I'm just going to take the top then, because when this equals 0 is when the whole thing will equal 0. So then I have 10 equals, so then I have 10 divided by 2.5 x squared. So what is 10 divided by? Is 4. So this is 4x squared. So this would be plus or minus 2 equals x. Let's see here. If I put in a plus 2, so let's try both. And actually, okay, what I didn't write in here, there's two parts of this. This said for positive, so we're only going to use the one. But I forgot to write that little problem. I was like, Okay, so if we were doing both of them, but you could easily do both of them if it hadn't said that. So now what I'm going to do is I need to find this graphing point. So it wants to know what this is. This is when it happens. To find the graphing point, I put it into here. So I'm going to get 10 times 2, 1 plus 0.25, 2 squared. This is 20 plus, let's see here, that's 4 plus 1, so this is going to be 2, so this is 10. So 2 10. Now, if this hadn't said, so this did say for it, then I would just simply go back and I would put in -2, and I would do the exact same thing. So I would do times -2, and then this bottom actually isn't going to change. It's still going to be 2. So then this would be -10. So this would be -2, -10. Now, as a reminder, you could check this if you wanted. I'm going to bring up Desmos here. Hopefully. Come on. I wanted you to just... Oh, it's mad at me. Okay. So then if I put in this equation, y equals, let's see here, it was 10x divided by 1 plus 0.25x squared. So you can see then here, right there, that's that point, and that's that point. This was actually a book problem I pulled up. They only gave you this half of the graph, but you can easily see, depending on what you're doing right there, this is, and that's the maximum point. This down here actually would be a minimum point. Now to find the minimums, we would go do the rest of the test, and we would be doing, you know, when is it coming from increasing to decreasing? This is the maximum because it's going from increasing to decreasing. So if I wanted to continue this, let me come back down here. Remember that then I would go on and I would go, okay, -2 and 2, and I put them into my first derivative, so this here, and so if I put in 0, let's see here, the top would be, bottom's always positive, so I only care about the top. I would get positive. If I put in a negative, say 5, I'm going to get 25. That number is going to be bigger, so this is going to be negative. And then out here, if I put in thing, this would also be negative. So then you can see here, down to up, that is a minimum, where this from up to down is a maximum. Okay. And the book's a little bit clear about their problem. I just scribbled down something like, hey, let's do this problem. But hopefully this goes through the steps, remind you of that, as well as what we're obviously our new skill this week is using the quotient rule. But we still have all those other skills we've been using, and we don't want to let them get dusty or rusty.